Okay, now let's review the remaining data types. Uh, as I have told you in previous videos and in some of the tests in the online compiler, there are two type of digital data types. The ones that can be signed, that is, that will take positive and negative values, and the unsigned, when you take only positive values, starting from 0 up to a maximum value. The short attribute for a variable or data type will be a reduced number of bytes to store, for instance, smaller numeric values. So remember, if you don't reach a very um, long values, you can use a reduced set of bytes to read them. And long is quite the opposite. You have an extended set of bytes to be able to store larger amounts. So let's have a look at this table. Uh, these are the remaining data types and their format specifiers, the number of bytes that they use for storing their data, and here it is the range of each of them. So let's start with the unsigned short end. It is a integer variable, but however it does not take 32 bits or the 4 bytes, just as a normal integer, but is quite actually the half, just 2 bytes. So you can have either that of this unsigned short end, which is 16 bits long, and go just for the positive values, as it says here, unsigned, from 0 up to this one. Or if you wanted to take positive and negative values, that is being signed, this amount of values will be split into halves. So you are going to have the half of this value for the maximum negative number that can be stored, and the same half of this value for the maximum positive number that it can store. So bear in mind something important. Here, whenever you do not use unsigned in the data type, is because it is assumed that it is signed. What do I mean by that? Here doesn't say unsigned, so it's going to be assumed that it will take uh, negative values and positive values. While in this that is called unsigned, you will have just positive values. Okay, bear that in mind. This U usually in the format specifier stands for unsigned values, just like in here. Okay, the next one is unsigned end. A normal integer value will have this range of values. These are the negatives, the positive side. But however, if you decide that it won't be taking negative values, that is, it will be unsigned. So there you have. It's going to be just positive from 0 up to this number. If it is going to take negative values also, so remember, you split this number, this range, into halves, and one half will be of negative values and the other one for positive. So remember here, this D stands for positive or negative. All right, while this U will stands for just unsigned values, I mean positive values only. Now let's see this for instance this unsigned long end. As you can see, it is an integer but of a very huge size. That's why it's called long, and it is unsigned just from 0 up to positive values, and there you go. long, and unsigned. Okay. The next one is this long end. Since it doesn't say unsigned in any part, it is signed. So as you can see, it takes half of this value to be negative and the other half to be the positive range. And it is long, and D. D stands for positive and negative values. Okay. The next one is the long double. Remember, for this real numbers representation with fractional parts. So we have here a now up to 19 decimal digits, and it is identified by this format specifier. Uh, this uppercase L, F, and it has a size of 10 bytes. And here's another simple example. Remember that if you don't tell this to be any type to be unsigned, it's because it is signed. So just like in car data type, you take from minus 128 up to 127. However, if you specified unsigned, it's because it's going to store just positive value from 0 up to 255. However, they have the same format specifier for either unsigned car or car. The last one, the last subject here is this size of operator that we are going to use in our code. If you apply within this parenthesis any of these data types names, you will receive, this will retrieve a integer value that will tell how many bytes any of these data types occupy. So if you write, for instance, size of this unsigned short end, it will retrieve value of 2. If you use this for long end, size of long end, it will retrieve the value of 4, and so on and so forth. It's a way to know what the size is of these data types. There can be some processors that have 32 bits, 64 bits, or even in some microcontrollers 16 bits. So that's an important tool that you can use to verify what is the internal size that it will occupy for any of these data types. Okay, now let's do some practice. I already wrote on in this comment section all the values, data types and their ranges, and the format specifiers. So let's start with this short end. This is for small integers, kind of similar to the car data type, but it has a much huge range than the car data type. So let's start with these values. Remember, if I state here short end, and there is no unsigned word, is because it takes both negative and positive values. Okay, remember that it has this D in the format specifier, so it takes both of both things. So okay, let's write, for instance, the value of the same value. Okay, and HD, and then pass the name short end. Oh, I forgot to give it a name, so yen. Let's say yen. So let's use this printf function, short end HD as format specifier, and let's run. It was written correctly. However, remember, if I ever go beyond that scope of values, it will have the wrong value, just like in here. Have a look. It is not the same number. It has the negative sign. So just as I told you, you can surpass the values. So now let's use this unsigned short end. If I use this value that is higher than that of this scope for short end, If I use the unsigned shorthand version, I will be able to store this value, but just because it is a positive value and it is within this range. So let's change and let's write unsigned. Unsigned. Okay, now bear in mind that if I change this data type here, I have to change also the format specifier. If I don't, I guess it will keep throwing errors. Yeah, it does the not the same name, but with the opposite sign. So let's use HU just for short unsigned, and here there we go. So what else? Let's go with this. For instance, unsigned long. Yeah, why not? Unsigned long end. Long end. And let's give it the maximum value here. Remember that we have to remove these commas of the order of digits. Oh, it's the comma. Okay, now let's see what happens here. We have to change this specifier. It's going to be LLU, I guess. Yes, it is. LLU. Okay. It is just a warning. It says that it's too large and it is unsigned, blah blah blah, but it's the same value here. So there isn't any problem. Now have a look at what may happen here. It is on long unsigned long end. So it will take this in this large range any of those values. However, just for the positive side. So if I write this value here and I press run, it will print the wrong number. As you can see, it is -8, but it is not prepared for negative numbers. I have to be aware of that. So I can use just positive numbers within this scope. However, if I decide to use any negative numbers, here's what we get. It actually is like the same amount here, but if we just like if I was subtracting the number 8 from them and gives me this value. So it tries to kind of compute the value, but as you can see, it does not write the accurate value, which is -8. So if I change it back to the long end, which would be signed because unsigned is not specified, what's its format specifier? LLD. Okay, LLD. This one is able to take any positive or negative values within this range. So let's see. -8. It is okay. So remember that. And now let's use this size of operator. So have a look at what we will write here. Here we have printf, and here is the space to write the value of this long end data type here by this variable called gen. And now I'm going to place a space or two spaces and a format specifier of d, that is, I'm going to write some other number in the same line. And what is the value for this number? Is the value calculated by the size of operator that I just told you. So here we are going to place, you can place either the long end, which is a variable, and this will calculate, will compute what's the size of this type of data type, and we'll write it in this line. So let's see. Oh, it throw me an error. Because it is long. I mistyped the G. As you can see, it prints it. This value or this long end data type minus 8 and spaces, and then a number which is the result of this operation, size of for long int that occupies 8 bytes. Remember, we already told here in this table. However, I can give it size of can also receive names of the variable. So I want to know how long is this variable called Jan. Remember that it is a long int, so it is the same 8 bytes. Okay, so you can use that size of operator